Hey everyone, and welcome to The Explainer. I am absolutely thrilled about today's topic, because we're going to unlock the secrets to solving some seriously intimidating mathematical puzzles. You know, if you've ever stared blankly at a math problem and felt like you just hit a massive brick wall, well, I've got great news for you. You don't need a bigger brain, you just need a better set of tools. So today, we're building a simple, structured mathematical toolkit that is totally going to change the way you approach numbers.
So you might be wondering, what is the actual secret to making complex math calculations easier? Is it memorizing a million different equations? Is it raw, unadulterated genius? No way! The real secret is that math isn't magic. It's simply about having the right tools in your mental toolbox and knowing exactly when to pull them out. When you know the shortcuts, the patterns, and the underlying structures, those completely impossible problems suddenly become, well, easy.
All right, let's look at our roadmap for today. We're going to cover 1. Highest common factors, 2. Rules of divisibility, 3. Dividing fractions, 4. Simplifying calculations, and 5. Collecting like terms. Let's get right into it.
Starting off with Section 1, Highest Common Factors. Think of this as your foundational tool.
Let's actually break this process down visually. Say we're looking at the numbers 28 and 42. Now, instead of just randomly guessing, we systematically find pairs of numbers that multiply to each, right? So for 28, we've got 1 times 28, 2 times 14, and 4 times 7. Easy. For 42, we've got 1 times 42, 2 times 21, 3 times 14, and 6 times 7. By just listing these factors out like this, we can easily spot the numbers that pop up in both lists. And the highest number that they share? It's 14. That right there is our highest common factor. It's systematic, it's clean, and it literally removes all the guesswork.
Now you might be wondering, why do we actually care about this? Well, who wants to deal with a clunky fraction like 16 over 40? Honestly, nobody. So we find the highest common factor of 16 and 40. By listing out the factors, we see the largest number that divides evenly into both is 8. By dividing the top and bottom by our HCF of 8, we instantly and pretty painlessly simplify that fraction all the way down to 2/5. This is the whole reason we need this tool. It takes the messy and makes it elegant.
Okay, moving on to Section 2, Rules of Divisibility. These are basically your mental math shortcuts.
So the crucial point here is that you don't always need to crunch the heavy numbers. You just need to know what to look for. For example, if the final digit is even, boom, it divides by 2. If the last 2 digits divide by 4, the whole number does. Want to check for 3 or 9? Just add the digits up. If the sum divides by 3 or 9, the massive original number does too. These little rules are going to save you a massive amount of time on tests and honestly, just in everyday life.
Let's see exactly how this works in practice. Take a look at the number 28,572. I mean, it looks pretty scary, right? But if we apply our rule for 3 and 9, we just sum the digits up. 2 plus 8 plus 5 plus 7 plus 2 equals 24. And since 24 is cleanly divisible by 3, but not by 9, we instantly know the answer for that huge 5-digit number without having to write down a single division bracket. It's basically a mathematical superpower.
All right, on to Section 3, Dividing Fractions. We're going to use the 3-step method. It's actually super simple. We use this exact 3-step scaffold to transform a confusing division problem into an incredibly easy multiplication problem. Step 1, turn the second fraction upside down to get its reciprocal. Step 2, just multiply the top numbers together and the bottom numbers together. Step 3, simplify using those factor tools we already built. And that's literally it.
Let's see this in action. Say we're working out 2/5 divided by 3/10. Okay, step 1, we take that 3/10 and flip it upside down into its reciprocal, which gives us 10/3. Step 2, multiply straight across. 2 times 10 is 20, and 5 times 3 is 15. So we're left with 20 over 15. Now for step 3, we use our previous factor skills. Both 20 and 15 divide cleanly by their highest common factor, which is 5. That simplifies to 4/3. Now that's an improper fraction, so we just convert it to the mixed number 1 and 1/3. Just by following the scaffold, a complex division problem basically solved itself.
Next up, Section 4, Simplifying Calculations. This is all about working smarter, not harder.
I want you to think like a mathematician for a second. The hard way involves multiplying really large numbers first, which creates these giant, terrifying fractions that take absolutely forever to simplify. So why do it the hard way? The easy way is breaking a fraction down into smaller parts using common factors way before you do the heavy lifting. By simplifying first, you save yourself from ever having to deal with gigantic, messy numbers. For instance, if you want to find 1/4 of 600, you don't need to set up a long division problem. Since 4 is just 2 times 2, dividing by 4 is the exact same thing as having a number twice. So half of 600 is 300, and half of 300 is 150. Done. Or look at finding 3/5 of 120. Instead of multiplying 120 by 3 to get 360 and then dividing by 5, there's a genius little trick here. Change 3/5 to the equivalent fraction 6/10. Dividing by 10 is incredibly easy. 120 divided by 10 is just 12. Then multiply that by 6 to get 72. We're just rearranging the numbers to fit how our brains work best.
Finally, Section 5, collecting like terms. This is our bridge right into algebra.
You know, algebra can actually be incredibly visual. Picture this. We have red bricks representing a length of x centimeters and blue bricks representing a length of y centimeters. If you put 3 red bricks together, you have 3x. But if you put 3 red bricks and 2 blue bricks together, you get 3x plus 2y. You absolutely cannot combine them into 5xy. Just like you wouldn't melt red bricks and blue bricks together into one single mixed up brick measurement, you can't combine different mathematical variables. We call this collecting like terms. You only ever group together the things that are exactly alike.
There's a sort of grammar to math, and standard practice shows us how to do this correctly. We write A, not 1A. We write 2A, not A plus A. We write AB, not A times B with a big X in the middle. Now, why does this matter? Because clean, simplified expressions prevent mistakes when the problems start getting longer and way more complicated. A good mathematician is a neat mathematician. And check out how all our tools come together in this fantastic example. This is Giovanna's method for simplifying algebraic fractions. We're trying to add 3a over 4 to 5a over 12. So she uses our tool of finding a common denominator, converting that first fraction to 9a over 12. Now they match, so she just adds the numerators together. 9a plus 5a gives 14a. She writes 14a over 12. Then she uses our very first tool, the highest common factor, to divide the top and bottom by 2, simplifying the final answer to 7a over 6. It perfectly merges our fraction tools with our brand new algebra skills.
I really want to leave you with this empowering thought today. Math isn't a mountain to climb. It's a puzzle to solve with the right toolkit. When you start looking at numbers not as obstacles, but as pieces of a puzzle that can be broken down with factors, divisibility rules, and common denominators, well, everything changes.
So, I absolutely challenge you to take these specific tools and use them on your homework or your next test today. I promise you're going to be amazed at how much faster you spot the solutions. If this explainer helped you level up your math skills, please hit that like button, share this with a friend who might be struggling with fractions or algebra, and be sure to subscribe so you never miss a chance to add another tool to your toolkit. Keep learning, keep organizing your thoughts, and I'll see you in the next explainer. After all, if math is just a set of tools, what other impossible problems in your life are just waiting for the right toolkit to be solved?